Okay, I'm kind of set up here, so what we're going to do is a repeatability check. I've got the taper hooked up, lead screws detached, and I've just got a rusty piece of junk on there right now just to test it. But I'm hooked up on the carriage with this dial indicator, and I'm hooked up on the bed with this dial indicator. And let me get these to zero out at the same time. I did a rough. Okay, I'm right on zero there. Yeah, I'm pretty good there. Let me get that one over there right on zero. I want to come in from the same direction. Backlash is always a factor. Okay, away and back. Okay, zero, zero. I'll do it 3 or 4 times, you know. And I'm just going off of this one. I'm going to run this one in until I see zero here. And I should see zero there. Good. Okay, so it's I'm 2 for 2. Oop, went past it. And like I say, you're always cutting in one direction, so it's always going to be on the approach to take out the backlash. Zero, zero. Okay, 3 for 3. Yeah, if we came in from the other direction, any little backlash is going to be evident. Zero, zero, 4 for 4. And I'll give you an example. Let's go beyond it. Let's go beyond but the carriage by, I don't know, 50, 60, 70, 80. There's 100 thousandths on the carriage. Now let's come back to it, approaching from the other direction just for giggles. Yeah, see, 6 thousandths change. So definitely has some backlash. It could be the ways here, the gibs. I've got the gibs set a little loose, so this thing floats really nice. It could be backlash in the bearings. It could be coming from anywhere, but you're always going to make your cuts in the same direction. So it's just like anything else, like the lead screw when you're threading. You always have to thread one direction or the other to get the backlash out of the machine. So we're used to that. All right. All right, I'll bring you back. We're done with this test. Okay, well, we're done with our tests. We're moving away from both indicators right now. As you can see, we're following this taper. I just cut something out of the scrap pile just to make a taper. Look at me go. Okay, so we're making a taper. My connection here is still horrible. It's just a bolt with a nut on it. That's all I had. I've got a series of holes. They still need to be reamed. We're going to be using a shoulder bolt with a very tight reamed hole to take out the slop. You don't want any slop in this little tube, bearing tube. It's a piece of 304 DOM tubing, and the linear bearings are here and here. And there is it's stainless. It's 304 DOM stainless, and there's a nut welded to the top of the tube, a 3/8 nut welded to the top of this tube. So that creates my attachment point, spreads the load out, and eliminates an awful lot of the bar deflection. I'm not going to say it completely takes it away, but because everything flexes. But I think we're getting ahead of ourselves. I've got the carriage lead screw nut out of it. I need to take all this off, and we need to start making checks. We haven't even thought about surface grinding our 2 base blocks or our 2 clamp blocks. We need to do some indicator checks and to find out how level and parallel and all that is, because we're going to check it before just to see how bad it is, because I expect it to be pretty bad, and then we'll do some surface grinding and see if we can improve upon that. Alrighty, so let's move on. We're cutting tapers though, but I got way ahead of myself. I gotta clean up this boat anchor. I got that out of the scrap pile. It's just a piece of 3/8 plate. All right, so let's put the lead screw nut back in, get all this malarkey off of here, and we will move on. Okay, ladies and gentlemen, I think we're set up here. I've taken my attachment off of the bearing tube. You get a better view of the bearing tube there. That's like I said, that was stainless steel DOM tubing, seamless tubing, and you can see I turned down the ends to get it concentric just on the ends. That way I could get in there and bore it with a steady rest and get it concentric. The center I really didn't care about, so that doesn't really matter. I'll probably just paint it anyways. So I think we're set up. Our carriage is capable of movement this way, and we've got our lead screw attached here so we can move in and out. And another thing you can view right now is my carriage width is 11 inches and my tube width is 10 inches. So 5 inches each way off of center. So essentially the carriage is going to run into the brackets before the bearing bottoms out on the clamps. So if I was to bring this, if these were synchronized and I brought this down, you see I'm hitting a bracket here, and if this is on center, I still have a full inch right there before I hit my clamp. So anyways, let's just put that in the middle for now. And we can't get all the way to the extreme ends, but we're going to come in with the carriage here, and I think I've already got this dialed in. I did this once already. And I'm going 1 full rev, and I'm gonna adjust this to 0. When I'm fishing around trying to find my highest high here. I think I got it there. And we're within a tenth, so. Let's see how that is. All right, we're happy there. So yeah, and that is a tenths gauge. I used the blue YouTube gauge for you guys. So our highest high is 1 full rev, and there's a secondary scale on there. I bumped the gauge. What a knucklehead. All right, we're happy. All right, so I'm going to come off far enough where I missed that tube on the way down. And if you guys are ready to go for a ride, let's go. And we're going to take it all the way to the extreme left here. And this is as far as I can go to get measurements. So whatever reading we get, it's going to be, the actual reading from end to end is going to be a little worse. We're off probably 4 or 5 inches off of each end. But if we get them equal here, the rest of it should follow suit. This is the best way I could think to measure without making some kind of swinging apparatus. Okay, 1 full rev. Coming around, it should 0 here. It's blowing by a thou and a half, and it's coming back down. So we're already within a thou and a half just with machine work. You know, so that's not terrible. Yep, exactly a thou and a half. All right, let's get it out of the way. We'll go back and check our 0. Try to do this without bumping the gauge or anything. And we're coming up on our extreme right hand stop. And we'll come back in again here. One full rev. Yep, and we repeat within a tenth on 0. So we're a thou and a half out over that measurable distance that actually worked. I'm just kind of setting up here in the center of the carriage. So pretty good. Not bad for machine work alone, and not to mention we've got raw stock on top. So surface grinding should make things better or worse. We'll see. All right, but this is where your tramming skills and things like that are really going to come in. dialing this kind of stuff in. So, and it should be noted that I put whey oil. I've never used whey oil in a linear bearing before. We usually just use white grease, but this thing just glides with whey oil in it, and it's kind of neat with that tube. We could actually kind of fill the cavity in there, so it's got a nice bath of whey oil all the time. So pretty cool. I might just put me a little oiling hole with a flip cup or something on there so I can just fill up that center cavity and let it flood out into the two outer bearings. Nah, I don't know. I'm probably overthinking it. Okay, let's get surface grinding. Okay, so we got started on our clamps. I chose to grind the bottom, basically the bottoms of the clamps first, and the reason is all this machine work out here was indexed to this surface. So this height was sitting up on parallels in the mill, so I had a better chance of them plopping down on the mag here, getting these squared up. Now I can flip to this ugly side, grind here, get them equal, parallel, flip one last time, and then we can do our little step in there and grind those equal to each other. So that's why I chose to grind this side first. Every time you look at a project, it's nice to know how it was machined, in what order. And if you do know that, that helps to select how to approach your grinding. I had a couple of inclusions that I don't really care about, so that's fine. This is just the bottoms of the tool. You're never gonna see it, so don't really care about that. I actually don't even care if I get inclusions in the top. You know, as long as I've got a flat deck and they're equal, I don't care if there's little pits and stuff in them. It's just cosmetic. I'll try to get them cleaned up, but I don't want to take too much out. Remember, as we grind this away, we're lowering our bar. And that affects some other things too. All right, so I'm gonna get back on the grinder and get this finished up. Just thought I'd shoot a little bit here, midpoint. Okay, we're back from the surface grinder on our second side. We've ground the tops of both of them, and all that's left now is to make sure that this little step is equal, and all we're going to do is drop them in the up against a fence. This is higher than the fence, and we're just going to get in there and dust those off and make them equal. We don't really care what the size is, just as long as they're equal. Over on the comparator stand, I checked them, they're within 1/1000, so they're pretty darn close now. So that's going to be the end of these things. They can go get a color put on them. Alrighty. Okay, so we're working on the headstock end. Our parts have been ground. We've got we cleaned the bed, we bolted it in, and now we're getting everything lined up, or we need to make sure it gets lined up. And right now, the only thing I can think of is that the way the bed is ground, it's ground downhill, because I'm getting an error, and it's the same on both of them, both the headstock end and the tailstock end. And what I'm going to do, I'm going to move my dial to 0 here, and I'm going to set my 0 on my indicator right here. All right, and I'm going to turn this 10 times. I'm going to record my error over 1 inch. So 10 turns of the dial is 1 inch. it's 100 thousandths per rev. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, so I'm seeing, what are we seeing there? 1, 2, 3 thousandths, just under 3 thousandths. Let's go another inch. We should be 6 if it's completely linear. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we should, I'm looking at my dial right now, we should see about 6 thousandths, which we do. Okay, let's keep going. We've got plenty of travel here. Let's go another inch, but from what I'm seeing here, we've got 3 thousandths slope per inch, and that'll be easy to fix on the surface grinder if we know what the error is. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we should be sitting about 9, which we are. We're like 8, and we're over 8.5, so almost 9 on that dial. Hopefully that gauge isn't blowing out. All right, so we're going to record this and go fix it on the surface grinder. And you know what's interesting is we're getting the exact same error on the tailstock end. So I just got to believe it's the way the bed of the machine is ground. So let's go try to correct that. Okay, and here we are down at the tailstock end, and same test. We're going to check it again. You know, these things would probably work fine because it's an equal error, but I want to get it flat, and the bar isn't always in the same position, both at the headstock end and at the tailstock end, and it's going to be changing elevations. But we're 0 on our dial. Again, we're 0 on our indicator, and we're going to travel an inch. 1, 2, 3, 4, 5, 6, 7, 8, 9, and coming around to 10. There's 10 turns. 1, 2, yeah, it's about 2 3/4, almost 3. Let's go another inch. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. About 5 1/4. So it's slightly less, but not enough to even make a difference, I don't think. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We're not going to bottom that indicator out on anything. We're good. So over 3 inches. Over on the other side, we were seeing about 8.5. Here we're at 5, 6, 7, about 7.5. So the error is about a 1/1000 difference over 3 inches. That's a 3-inch span we just measured. All right, let's get over on the surface grinder and try to correct this this thing. Okay, just before I start grinding, I thought I'd just kind of prove it to myself. I want to check this flat way and see if it's parallel or if it slopes down. Maybe the manufacturer intended for it to have a little bit of runoff or a taper of some type. Who knows? I can still see the original grinder marks down here. This is the tailstock end. The carriage hardly ever gets down here. So this is actually a pretty good place to measure. I am set on, let's come until it falls off. Okay, we just fell off. So I got a 1/1000th preload. And I'm going to come up to my 0 here. And I'm not going to be able to do a full inch of travel, but I can do a 1/2 inch. So I can do 5 dial revs and see if there's a see if that thing slopes down the way the bars were. So let's see if and a small pad like this with the clamp has an awful lot of influence on that bar sticking out. That's just like a 6-inch or 7-inch bar. All right, here we go. 1, 2, 3, 4, 5. Right there. Are we falling off? No, we're not falling off the way. We're right on. Okay, that's 5 dial revs. That is, put some glasses on, 3/10 running uphill. So that would influence our bar and send it to tip downhill. We can check it down here where we've got where we've got a little more wear. It takes a while to get the indicator set up, but I'm going to flip it over to the other side, on the side of the bed that has the most wear, and we'll check it again down there. And I expect this to be pretty worn out here. This is kind of the working area. And I'm not going to even get into rebuilding this machine. Okay, let me get to 0 here on the dial, 0 on this dial. I think I could probably go out one more. Let's start off there. Okay, 0 on the dial, 0 here on this dial. 1, 2, 3, 4, 5. So that's pretty substantial too. You know, that's a pretty good ramp. 6, 7, 8, almost 8/10. So you know, it matters wherever you put this on your bed condition. But like I say, I am not prepared to go around and rebuild this machine just because I want to put a taper attachment on. This attachment has to be forgiving enough to work properly with a worn bed, because machines definitely don't stay perfect. Okay, well, we just made a quick correction. 2 pieces of paper. If you mic them, they're about 6 thousandths. So we tipped that thing up 6 thousandths over 5.5 inches. So that's our first correction. Let's see if it did any good. And we just dusted it, man. We're not even taking off a thou, or you know, just a couple of tenths is all it takes to clean that up. So let's go check this and we'll bring you back. Okay, well, we're back from our first grind, and we thought we'd see how we do. If you recall, we were getting 3 thousandths per inch of travel, and I'm ready to make my sweep. I've got just a slight preload on this little fella, and I'm zeroed out. I'm zeroed on my dial, and we're going to go 10 turns. I've switched to a tenths indicator, so you're going to see a heck of a lot more needle movement this time. Let's do 10 turns. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we're seeing we went from 3 thousandths to 2/10 per inch of slope or run out or whatever. And what I've discovered is when we even moving it up and down the bed a little bit, it doesn't change this drastically, but it does change it. So it matters where you put it on the bed, if it's on a worn section or a clean section. I'm back here by the tailstock, hardly ever gets used. I do know that my bedway is clean. I did rub it down with a Renzetti stone to check for high spots. Nothing there. One stroke and I knew it was fine, but I did verify that. So 2/10 over an inch. I don't think I'm going to try to get it any closer, because I'm getting a couple of tenths of variation depending on where this bracket gets bolted. So I don't think I'm going to chase it anymore. All right. I attribute that to the bed wear and things like that, and I'm not going to get into rebuilding this machine just for a taper attachment. Alrighty, but same thing up on the headstock, and we're going to move on to our clamp blocks and elevations now that we're happy with the parallel. Okay, I think I'm set up for some bar checks here. I've got the bar running just eyeball parallel. It doesn't really matter for this exercise, but we're going to check the bar in tight to the carriage, and we're going to move it out and check it out there too, just to be thorough. And all I'm doing is moving the carriage in and out until I fish around and find my high spot. And it looks like I got a good 0. All right, so let's get the indicator out of the way and move us down and check our extreme left side. We're heading down to the headstock end. Okay, so let's fish in here and find our highest high and see where we're at. Holy crap. Wow, even a blind dog finds a bone some days. Okay, so 0-0, pretty happy. We're going to go ahead and move these clamps out to the outer extremes and parallel again, but way out at the end, just for a second, kind of a parallelism check and a elevation check. Okay, I think we're set up again. Bar moved away from the bed to its outer extremities, and we're going to come in and fish in again. We're looking for our highest high out there. We're going to zero up on that. Okay, pretty happy there. Move down and just check it in one more spot. A little low. Move over a little bit. Yep. Alright. Alright, let's head down to the headstock end and see how far out we are. We already know our parallelism is good, so it should, you know, if I'm within a half a thou, I'm a pretty happy guy. There's your half thou. Alright, yeah, it's a little low. Not too bad. I was doing one check and one of my clamp blocks wasn't tight. Big difference. About a 2 thou difference when you tighten that block up. Yeah. Pretty much back to zero. Yep. And we already know the bar is, I don't know, you can see there's the sag in the bar. So you're in the center of the bar. You can just barely see it. And there's your bar deflection there. That's just the weight of the bar sagging down out at the ends. So this is about the best check I can do with the indicator dead center and take it to its extreme left and extreme right. Yep, there's back to your half thou. So I'm pretty happy there with parallelism, elevation, and running true to the bed. So pretty happy with everything we've got here so far. Now we need to put our slide tube back on. I've already showed you that, and finish the attachment to the carriage. Okay, well, we've got our stuff all installed again. Our bearing tube right here is installed, and I'm still hooked up to the cross slide nut, so I've still got that. I need to disengage that. I need to figure out this connection here from this tie plate. I made a little bar that goes across where you take off the guard and bolt up the original holes. This bolts into the top of that. That is a 3/8 stainless steel nut TIG welded to the top of that tubing, and I've just drilled 3/8 holes here. You know, but I went out and got a shoulder bolt. It's got a 1/2 inch shoulder, so I'm going to drill and ream all of these out to 1/2 inch and just let this kind of float in there for elevation changes and things like that, and see if that works. You know, see how much play we get in it. You know, remember this tube can rotate this way. You know, we can, so that could cause a problem if we don't make that connection nice and solid. So let's try it with just drilling and reaming the holes here. I'll bring you back after I get those drilled and reamed. I'm going to cut a very tight hole to that. All right. Okay, well, we've got our series of holes drilled and reamed. I used a chucking reamer, went out to 4995. The shoulder bolt, 4995. So very little play, but that tube still wants to rotate. I'm just turning that tube by hand, and you can see the carriage moving. I've got the lead screw nut out of the carriage right now. So that's going to create backlash. When I go in this direction, see we're tapering now. When I go the other direction, you can actually see this tube roll over. Watch that connection right there. I don't know whether you can see it. I can certainly see it. And you know, a little bit of backlash, you can work around it, but eventually I think this is going to pound these holes. There's all your carriage movement right there. So I think I'm going to go to plan B and drill these. I want to improve this connection. I think I'm going to drill these and drop in drill bushings and let the shoulder bolt ride in a taller drill bushing and see how that runs. Okay, I'm back, and I just wanted to try one. So I've got a drill bushing in this first hole. If it works, I'm going to just slip around and do the other ones. I did make sure that the bushing is slightly shorter than the shoulder bolt, so that it doesn't ever pinch down on the shoulder bolt, or the shoulder bolt doesn't pinch down on the bushing. How's that? And all right. So now with that extra height, I don't see any rotation there, and we are tapering again. So I think I'm going to go ahead and drill and ream all those and put bushings in every single one of them. So I've got a nice series of holes, and I've got a good connection there. I'm actually pretty happy with that right there. I wonder if we can make a cut in that one hole that I stuck it in. We can try. Let's set up and make a cut. Finish looks pretty good. It looks like a straight cut. I'm going to lay this white piece of paper there, and I think I've got the camera aimed right. I'm just going to lay a little scale right on there and look straight down at that white paper, and you shouldn't see anything. And yeah, I'm going to tip it left and tip it right. I can't tell if the camera's seeing it right, but I'm eyeballing it and it's nothing. So I've got a nice straight cut. Pretty happy with this setup. So my bushing trick here worked. All that's left to do is do the rest of this series of holes with bushings in each one. These are just 5/8 by 1/2 inch drill bushings. That's all they are. So they got a 5/8 OD and a 1/2 inch ID. And after you drill the hole, you just you ream it and pop them in. And I'm pressing them in at a very specific elevation to make sure they don't influence that bar in any way, lift it or push it down or anything like that when we tighten here. All right. That's pretty much the end of this project. I hope you guys enjoyed. But as you can see, we are tapering. Alrighty. Thanks for watching, everyone. Okay, here's a few final thoughts. I really struggled with this connection right here, getting it right. And I don't know whether I'm still entirely satisfied with it. I still think it's going to influence the bar in some way, even though we really don't feel anything. You know, it feels just really nice on the way in and on the way out. It just feels really good. But I still believe that it's influencing the bar in some way. I think if I had it all to do over again, this bar, I would probably build some kind of a spring steel flexure in tight right here. All you're doing is putting a load in this direction, or a pull load or a push load. You know, this thing could hinge up and down and it would be fine. If we had a flexure across here to allow that to compensate for the bar movement, this whole setup would be a lot more forgiving. I spent a lot of time doing surface grinding and getting these pads parallel and flat and everything else and equal to each other. And if with a simple flexure right here, this thing just becomes so forgiving that the bar and any of these other components don't really matter anymore. I mean, as far as mechanical accuracy of your angle, yes, it matters. But as far as it actually functioning right, I went to a lot of trouble to get it where it is now. And it's probably very easily knocked out of this alignment, you know. You need to be able to take care of these things. It needs to be stored in a box and all that. But that's my hindsight on this whole thing. Alrighty, appreciate you guys watching. And we'll catch you on the next one. Hope you enjoyed the lathe taper attachment.